Is my screen visible? Okay. So today, I'm going to start the chapter number 3 that is already mentioned in your Google Classroom. That is theory of estimation. So theory of estimation is what? What are you estimating? Anyone? Can you tell me what are you estimating till last chapter we are estimating something. So what are you estimating? So we are estimating the population parameter, which is unknown, right? We are estimating the population parameter, which is unknown. And we are estimating that by using the sample statistics. That is called estimation. So estimation, we can say estimation is a actually these are under the statistical inference. Inference means where you are taking some decision by checking the sample statistics and the population parameter. You are estimating something that is called, or you are taking decision that is called the statistical inference. So the process of selecting the samples and their using of that sample statistics to take the decision, and which decision we are taking? We are taking the decision about the population parameter. That is called the statistical inference. And it is of two types. One is estimation, that is called theory of estimation, which is your chapter. Another is test of hypothesis. So in we will study the estimation, the theory of estimation. So when the population is small, then we know that it is not a problematic situation to get the population parameter easily. Population parameter means, suppose you have a population of a small size, you can easily find out the mean. You can easily find out the standard deviation and standard deviation, variance. These are all population parameters. But when suppose I am giving you a population size of 10 to, or 20, you can easily find out the mean, the variance. But if this is large, that will create problem to find out those population parameters. So when the population size is very large, almost you can say it is infinity or large. It is large to calculate for unknown parameter sample. Then the population parameter value is approximated by sample statistics. Then what you do? You take some samples, you draw some samples. There are different sample drawing methodology, you know. So you take some sample and you do you find out the sample statistics. Statistics means the sample mean, the sample variance, standard error. These are the sample variance. So when the population size is very large, then you are going to take the sample statistics, and by this using on the basis of sample statistics, you approximate the population parameter. So that is called the estimation. That is called the statistical estimation. So it is not, it is, but the approximation of population parameter using the sample statistics is known as the statistical estimation. Is it clear? Is it clear? Are you going to understand this? Are you able to understand what I'm trying to say about the estimation? What is estimation? Why? How do you do? That is the basic knowledge of estimation I have given. Now we can see there are several types of estimation, like point estimation, interval estimation, like this. So what is point estimation? Though point estimation is the statistic that is used to estimate the unknown the population parameter. That is known as the point estimation. The which you are using To estimate the population, to estimate the unknown population parameter is known as the point estimation. So, if a statistics which is used to estimate the parameter is called the point estimator. Now, another estimation is interval estimation. So, interval estimation is also in point estimation you are estimating a particular value, a particular statistical value will estimate the population. But the interval estimation is just like interval. Interval means a span of কি বলবো value মানে a channel of মানে a span of values, right? A span of values. So in interval estimation, uh, we can state two values between which the unknown parameters, unknown population parameters lies. That is the span, that is the interval, is known as the interval interval estimation. But which interval will you select? So that depend. That is why it is important that the probability of your statement must be very high. That probability of your population parameter lies in the interval of values must be high. That is called interval estimation, and that is why it is called so so specified by two limits. This interval is known as confidence interval, right? So that is called confidence interval. So in particular, the two-tail distribution, right? In two-tail distribution, what happens? There are some critical values for right tail and also red tail. So this internal acceptance area, that is called the confidence level, confidence area. So these are some real life estimates we can do. So these are the real time estimates. You please go like a manufacturing company may be interested to estimate the average life of its product. So it is not possible, right? Because your population size is very high. But average life of its products, it is not possible to find out with the population, because population parameter is not known. Right. So what will you take? You can take of for the last 2 years or for 3 years samples, and you can take what is the average life of that product, those products. So that is what, like those we do the theory of estimation. Then a manager may be interested to estimate the average number of customers coming to a service center per day. So it is also because your number of trial is big, number of person in inserting in a service center is very large, right? So it cannot be predicted. So to predict the average number of customers, so you may do with the sample of some time from some particular particular interval time you can take. Suppose for 10 to 2, how many people came? Or from 10 to 1. That is from 10 to 2. It is also a very huge number of population will be there. So you have to take very small size of size of sample. So you may take for half an hour how many people come. So like this, you can take several samples, and you will get the estimated value of the average customers per day. So like this way, there are different examples you can see. These are for estimating those values of population parameter, we use theory of estimation. So in point estimator, we can denote the point estimator in terms of theta. Now, what is theta? Theta is a parameter which is unknown of the parameter population which is unknown, and if the random sample of size n, like x1, x2, xn are drawn, then we can say theta, the population parameter theta, is the function of the sum of the sample, and if t is the point estimated of parameter theta, so we can say t is obviously it is called the point, because without knowing the population parameter, how can I find out? So we need the estimation. So if t is called the point estimator of a parameter theta, we don't know what is the what is t, what is theta, right? So if we take if we assume t is the point estimator of parameter theta, the value of t is known as the estimate of parameter theta. So we can we can estimate by calculating the value of theta, we can estimate the parameter theta. Yeah. So if and for estimating, we denote not we did we can denote the estimator that is to you in terms of theta cap, because theta cap is estimating value. It is not exactly the parameter value, right? So we can take as theta cap. So we can write theta cap is a function of t of t function of x different samples of sample size of n. So here t is a random variable because it is a function of sample observation, obviously. So this is a function of sample observation x1 to xn, like this. So there are some properties to be a good estimator. A good estimator must be unbiased, uh, consistent, as well as efficient. So sufficient also. So these are the four properties of Google to be a good estimator. So a good estimator has the first property is the unbiasedness. So you know what is unbiasedness, what is biasness, that is already known. So the most desired property of an estimator is unbiasedness, and estimator T is said to be an unbiased estimator of parameter theta if estimator of T is equal to theta. That is, then we can, if expected value of T is equal to theta, expected value of sample statistics is equal to the population parameter, then we call it as unbiased. We call it as unbiased. But if it is not, if does not equal to the population parameter, then we can take the statistic as T star. Then we can say that T star is not, we can say T star is biased with theta. So that is the unbiased. So we always prefer unbiasedness of a estimator parameter. Clear? So if the bias, if this is the T star is the biased estimator of theta, and if T is the unbiased estimator of theta, then we can say the biased value of the estimator will be expected value of T star, that is biased value, minus unbiased value. That will be the bias. How much bias that is done. So it is represented with a graphical representation. You can see this is for unbiased estimator T. It's a sample distribution. And if population parameter, suppose theta, suppose it is mu. So if mu is same as the estimate value of T, so it is unbiased. And if it is not, then it is called biased estimator. If they just say T star is not equal to theta, the population parameter. So we can say it is the bias estimator. How much bias? T star, that is called is T star minus theta. This value of bias is containing this distribution. Now the second property is the consistent. For to be consistent, parameter theta, to be constant, if T is a consistent parameter estimator of parameter theta, then remember that can be possible only when T is tends to theta with probability 1 as n tends to infinity. That is how we can see. For example, you know, this is for a simple random it's a simple random sampling with replacement. So here we know the formula Vx bar is equal to sigma square n. So the to be consistent, the n must be if n tends to 0, then what will happen? If n tends to 0, so Vx bar will be tends to if n tends to infinite, if the sample size is very high, then Vx bar its variance will be very small. So that is called the consistent. Clear? So to be consistent, this condition is very important to remember. That is, if ET tends to in theta, VT tends to 0 when n tends to infinity. So that is, please remember this part. Then the parameter, the estimator to be a good estimator, it must be efficient, quite efficient. So what do you mean by efficient? Is value is remains stable from sample to sample. That is efficient. Matter when your efficient, that means your must not change from sample to sample. That is called efficiency. So a relative efficient. So for t and t star, for two estimator of theta, the variance of t must be less than variance of t star. Obviously, because you know your must be smaller. To be a good estimator, must be smaller. So you can calculate the efficiency of t by this formula, variance of t0 by t. So what is t0? T0 is the best estimator, most efficient estimator for estimating theta, and this efficiency is always smaller than 1. If t and t0 are same, then the efficiency becomes 1. Clear? And the last one is sufficiency. That is, an estimator is said to be sufficient if it possesses all the information about the population. That is called sufficiency, because whenever you draw a sample, that sample must have the all information about the population. That then only your estimation will be good. Right? If you have less information about the population, your estimation may not be good, right? So that is called the sufficiency. And now, the which type of estimator we can prefer? That those are the preferred estimator. So the preferred estimators among all the unbiased estimator of theta, the minimum variance, remember, the minimum variance unbiased estimator will be preferred to estimate the population. Your estimator must be with minimum variance and must be unbiased. That is, in a short, it could be called MVUA. That is, minimum variance unbiased estimator is the estimator which has the minimum variance, and it is the preferred one. So therefore, if the statistic T be the minimum variance unbiased estimator of parameter theta, then expected value of T is equal to theta, that is unbiasedness, and obviously minimum variance. That means variance of T will be less than variance of T star. So this is the condition we should prefer for the estimation. So now there is some statement which you have to prove. That is, if x1, x2, xn be randoms. Acha, till now, is there any queries?
না ম্যাম।
বুঝতে পারছো তো? বুঝতে না পারলে please ask me. Okay. So now, just see this part is already known to you. They have copied it from the previous cases. That is, if x1, x2 to xn be the random sample of size n, this idea you already have. Size n from an infinite population with mean mu and variance sigma square. Then we can say that is x bar is equal to 1 by n summation of xi from I equal to 1 to n is an unbiased estimator of mu. This already know, you know. And you already know small s square is equal to 1 by n minus 1 summation of I equal to 1 to n xi minus x bar square. This is nothing but variance. This is the formula of variance, right? But this is the formula of variance, but in terms of in sample, because when you do the sample, we take this this n minus one, because with the on the basis of degree of freedom, we know when you use the sample, degree of freedom becomes reduced by 1 unit, right? This already I already shown you. I already have shown you. I already gave you a notes of my handwritten notes that is done here. That is done in that notes, that how it is coming. And this is, you know, that a square is an unbiased estimator of sigma square. This part you know, that is sample variance. A square is unbiased estimator of population variance. This is sigma square is population variance. And x bar is sample mean, that is unbiased estimator of population mean. So how this is proved? Is already you know how to prove this. Already it is done in previous classes. That is expected value of x bar. X bar means sample mean. So sample means is summation of sample by number of sample. So expected value of summation of sample, if x summation samples are x1, x2 like this up to xi. So up to xn. So we can say summation of xi from I equal to 1 to n by number of sample n, because we are taking I 1 to n. So by 1 by n. So from here we can say, if you because this is constant, 1 by n is a constant. So when you do expectation, so when what do you do? 1 by n will come out, then summation of expected value of xi. So expected value of xi, summation of expected value of xi, you know, that is what? Only E of xi is equal to mu. E of xi is equal to mu. This is already known to you. E of xi equal to mu. But summation of I equal to 1 to n. So n times mu. That is why you can say n times mu by n, that is mu. So this x bar is unbiased estimator of mu. Unbiased estimator of mu means there is no other no other ki bolbo, no other variables are there, only mu is there. So you know mu is the population mean. Mu is the population mean, and x bar is the sample. So from this proof, we can directly get E of x bar is equal to mu. That means you are estimating mu by x bar. So it is not biased, it is unbiased. E of x bar is equal to mu. Like the formula E of t equal to theta. Because E of t equal to theta. Here theta is the population parameter and t is the sample parameter, right? So here the sample parameter is x bar and population parameter is mu. In terms of mean, in terms of average, the sample parameter, sample statistics is x bar, population parameter is mu. This is t, this is theta. So our formula is like Et equal to theta. So it also follows Et equal to theta, E x bar equal to mu. So we can say x bar is unbiased estimator of mu. Is it clear? Is it clear? যদি বুঝতে না পারো প্লিজ আস্ক মি। হ্যাঁ বলো। হ্যাঁ হ্যাঁ সেটা তো নাম্বার অফ পসিবল স্যাম্পল ভ্যালু। দেখো এটা হচ্ছে, এখানে কি বলেছে উইদাউট রিপ্লেসমেন্ট বা উইথ রিপ্লেসমেন্ট? এটা তো সিম্পল র্যান্ডম স্যাম্পলিং নেওয়া হচ্ছে, হুজ পপুলেশন মিন ইজ মিউ, ভ্যারিয়েন্স ইজ সিগমা স্কয়ার। ঠিক আছে, তাহলে তার থেকে যদি আমি একটা স্যাম্পল নিই, সেখানে আমাকে তোমার তুমি দাঁড়াও জাস্ট আ মিনিট, আমি তোমাকে একবার দেখালে তুমি বুঝতে পারবে। Just see, sample, যখন sample mean we are finding out the sample mean is what, number of samples, মানে ডিনোমিনেটরে থাকবে কি নাম্বার অফ স্যাম্পলস, এন্ড নিউমারেটরে কি থাকবে, যে সামেশন অফ স্যাম্পল। ক্লিয়ার? এটা দিস ইজ দ্য জেনারেল ফর্মুলা। এন্ড তুমি যেটা যেটা বলছো সেটা বলছো যে if you draw the sample SRSW in this scheme or SRSWOR, then the population, তখন তোমার কি হচ্ছে, তখন দেখো এখানে বলা হচ্ছে that after is drawing, but here you don't know about the population size, right? Do you know the population size here? না, ক্যাপিটাল এনটা কি, ক্যাপিটাল এন পপুলেশন সাইজ, তাই তো? মানে সেখানে পপুলেশনটা তুমি জানো, দ্য মানে সাইজ অফ পপুলেশন ইজ নোন, এবং সেই পপুলেশন থেকে তুমি স্যাম্পল নিচ্ছ, তখন তোমার আমার উইথ রিপ্লেসমেন্টটা কি হচ্ছে, স্যাম্পল যেহেতু আমি ফেরত দিয়ে দিচ্ছি, তাই পসিবিলিটি একই স্যাম্পলের উপর কতবার নিচ্ছে, তাই জন্য এন টু দি পাওয়ার এন, ক্যাপিটাল এন টু দি পাওয়ার এন। আর উইদাউট রিপ্লেসমেন্টে যেহেতু কমিয়ে যাচ্ছে, তাহলে ওই এনসিএন ফর্মুলাটা আসছে। বাট এখানে তোমাকে এস্টিমেশন আমি কখন করব, আমি প্রথমেই বলেছি, দেখো প্রথমে আমি বলেছি যে estimation is done when the population size is very large। দেখো দাঁড়াও, এখানে কোথাও লেখা আছে, হ্যাঁ, when the population is very large and unknown about your population, you do not know anything about population, then how can it be possible? Then you are taking some samples, সেখানে আমি with replacement, without replacement I cannot say, because I don't know the capital N, right? So we can estimate that if I take small n number of samples, then we can get the mean, the average, that is summation of xi from I equal to 1 to n, 1 by n. Is it clear? আচ্ছা, জানাই নেই তো, in this way I can find out the mu। তাহলে এখানে দেখো E of t equal to theta, this formula follow, we can follow this formula, Et equal to theta, t টা কি, capital T is the sample statistics, তার মানে স্যাম্পল এর সম্বন্ধে কিছু ইনফরমেশন, and theta is the information about population, that is population parameter. So x bar is sample mean, mu is the population mean. So we can say this is unbiased estimator of mu. And what about Vx? So this is the code, এটা কিন্তু s square is sample variance. So you have to prove that small s square is unbiased estimator of sigma square. And how to find out the variance? We know the formula. If I find out the variance of sample mean, how do I find? Variance of x bar is equal to variance of x bar means same formula. Just put this and 1 by n constant. So when for the with the rule of variance, we know it will become square when you take out from the bracket. So it will be 1 by n square summation of I equal to 1 to n variance of xi. So variance of xi from I equal to 1 to n, what is the variance of xi? For a sample of size n, we can say it is sigma square. we can say it is sigma square. We know this is sigma square. Variance of xi. If you take the sample x1 to xn, so we can say it will be the variance. We know the variance of xi is equal to sigma square. So how many times you are summing? N times. That is why n sigma square, and this is n squared. So we can say sigma square by n. Clear? Now, so a variance of x bar is equal to sigma square by n, but we have to find out, because this is sample, this is the population variance sigma square, but we have to find out the sample variance, right? Sample variance. So that is sample variance is expected value of summation of I equal to 1 to xi minus x bar whole square. This is how we find out the variance. And that is I square minus nxi nx bar square. This is how it is written. This is not that is a minus b whole square. That does not right. It will be xi square minus n x bar square. For more information, you can find out from any YouTube channel. You will get how it is coming. Then that will be expected value of xi square minus n expected value of x bar square. So expected value of xi square, and this can be written in this formula, because you know variance of x is equal to what? Variance of x is equal to E of xi square minus e square xi. That formula. No, it is not in this form. The formula is not given here. Maybe it will be in the it will be in this chapter. This is the formula. Variance of x equal to ex square minus e square x. So here e of xi square is given. Just see. So e of xi square, that is will be equal to variance of x plus e square x. So we can write e of in terms of sample, we can write e of xi square can be v of xi plus e square xi. Is it clear? From this formula, you can easily write this. And this one is minus in e of x bar square. So e of x bar square, that means e of x square. It is also variance of x minus e square x bar, variance of x bar plus e square x bar. So by putting those formula, we can easily do what is v of xi. V of xi, variance of xi is equal to sigma square. How many times? So we will do the summation later on. So this is sigma square and is e square xi. E square xi. E of xi means mu. So e square xi means mu square. So it is mu square minus n v of x bar. V of x bar আমরা কি জানি? That is sigma square by n. So write sigma square by n plus e square x bar. E square x means mu square, because e x bar equal to mu. E of x bar is equal to mu. So e square x bar equal to mu square. Just put the values and you will. So this is the thing, but n sigma square. This is summation of n. I is equal to 1 to n. So we can write n sigma square, and this is n mu square minus n sigma square by n minus n mu square. So n mu square will cut out. So we will have n sigma square minus sigma square. That is n minus 1 sigma square. So, so from these you can say just a minute. This is the variance of sample, variance of sample, and that is a square. A square is equal to this, that is unbiased estimator of sigma square. So from here we are not directly getting a small a square. So a square is equal to this is an unbiased estimator of sigma square. How? Because দেখো n minus 1 আর এটা কি বলেছে e of xi minus x bar whole square. So if this equal to n minus 1 sigma square, so we can write e of this by n minus 1 is equal to sigma square, and e of this by n minus 1, that is nothing but e of that is nothing but a square, right? That is nothing but expected value of a square. So expected value of a square is equal to sigma square. So we can say a square is unbiased estimator of sigma square. Clear হয়েছে? বুঝতে পেরেছো? দেখো এখানে n minus 1 টা রয়েছে, that is equal to this. So if I just keep n minus 1 to the left side, so it will be by n minus 1. So this is nothing but expected value of a square, because summation of I equal to 1 to n xi minus x bar whole square by n minus 1, that is equal to small a square. This is the formula. So if you take n minus 1 to the left hand side, so it will be like this, and that is nothing but expected value of a square is equal to sigma square. So again we are getting e of t equal to theta, so that means a square is unbiased estimator of sigma square. It's very easy. But if you do in terms of capital S, you know the capital S means when you do not you do not assume that your degree of freedom is decreased by 1. Then if you just take as small n without minus 1, then you can say the sample is capital S. You can say this. Then it will be like this. So that will be e of and that formula is like this by n. So here we'll be get n minus 1 by n, this factor we'll get. But here you see e of capital S square is equal to n minus 1 by n sigma square. So extra factor you are getting n minus 1 by n. So this formula does not follow e of t equal to theta, right? Because n minus 1 by n, this factor is coming. So we can say capital S square is biased estimator of sigma square. That is why we always during the sample we always take small square, because we know estimator must be unbiased. That is why we always take small square, and because small square is unbiased estimator of sigma square. Clear হয়েছে? If you do not if you follow the degree of freedom perspective, if you take the sample size with minus 1, then you will see that your sample variance will be unbiased estimator of sigma square. But if you do not bother about that, if you just take only number of samples in, then you will see that will be biased estimator. So we do not prefer biased, right? We always prefer unbiased estimator. That is why this is this we always prefer. This part we always prefer. So now a small example is given. Just see, if T1 and T2 be the two statistics with if ET1 equal to 2 theta 1 plus 3 theta 2, ET2 is equal to this. Find the unbiased estimator of parameter theta 1 and theta 2. What will be the unbiased estimator of parameter theta 1 theta 2? You cannot say T1 is for theta 1, T1 and T2 is for, no, because ET1 is equal to this and ET2 is equal to this. So how to do? Very simple. Take these two equation, and after solving, you can solving for theta 1 and theta 2, you will get theta 1 is equal to this 3 ET2 minus ET1, and that can be written as E of 3 T2 minus T. And theta 2 will be found out like E of T1 minus 2 ET2. That can be done, that can be written as E of T1 minus 2T2. So again, you are getting the same, you are following the same, that is Et equal to theta. So we can say 3T2 minus T1 is the estimator, unbiased estimator of theta 1, and T1 minus 2T2 is unbiased estimator of theta 2, because it's following the Et equal to theta, this form. Clear? Is it clear? Very simple. দেখো যদি অসুবিধা না হয়. Okay, now you see this question. It is if T1, T2, T3 are independent unbiased estimator of theta and all have the same variance. Remember, and all have the same variance. Which of the following unbiased estimator of theta would you prefer? You got the question? If T1, T2, and T3 are independent unbiased estimator of theta, all are independently unbiased estimator of theta, and all have the same variance, like sigma square, then which of the following unbiased estimator of theta will you prefer? So how to do? So you have to find out, in terms of variance, you have to find. So what have you learned? You learned that to be a good estimator, your variance must be very less, right? এই যে এখানে বলেছে না, to be a good estimator, your variance must be less. So you find out this you find out the variance for each case and see which one has less variance. Then you will be able to find out the preferable unbiased estimator of theta. Can you do it? Can you do it? Can you find out the variance of this? Very simple. Variance of T1 plus T2 plus T3 by 4 is what? How to find out this? All have the same variance. T1, T2, T3 has same variance. So we can say variance of T1 equal to variance of T2 equal to variance of T3 equal to sigma square. Now you can find out the variance of these three. Can you do it? Okay, you just do it and tell me which will have the less variance. সবাইতেই সিগমা স্কয়ার কি করে থাকবে? এখানে তো এইগুলো দেখো, কোফিশিয়েন্ট গুলো দেখো, মানে 2 আছে 4 আছে, এগুলোর জন্য তো চেঞ্জ হবে। দেখো ভ্যারিয়েন্স অফ T1 plus 2T2 plus T3 by 4, তাহলে এখানে 4 কনস্ট্যান্ট, তাহলে 4টা বাইরে আসলে কি হবে? 1/16 4 স্কয়ার, and variance of T1 plus 2 variance of 2T2 মানে কি? 2টাকে বের করব, 2টা কনস্ট্যান্ট, তাহলে স্কয়ার হয়ে যাবে 2টা, তাহলে 4 variance of T2, that is sigma square. So দেখো করে, just see, এবার দেখো variance of T1 plus 2T2 plus T3 by 4, তাহলে 4 টাকে তোমাকে বার করতে হবে, this is constant, 1 by 4 is constant, so 1 by 16, 4 square. You know na, variance of bx is equal to b square variance of x, this part you know na. Variance of bx, b is a constant, is equal to b square variance of x. এইভাবেই করবো। So তাহলে কি হবে, তাহলে individually I can say variance of T1 plus variance of 2T2 মানে কি, it is b square, তাহলে 4 variance of T2 plus variance of T3. So variance of T1, T2, T3 all are same, so এটা এখানে একটা v হবে, v of T3 হবে, হ্যাঁ। So they are sigma square, this is 4 sigma square, this is sigma square, so we are getting 3 by 8 sigma square. Clear? And this is the next one, 3T1. It was simple, 1 by 4. This is 9 bit sigma square. This is sigma square minus 4 no, plus of minus 2 whole square. That is 4 sigma square. So that will be this 7 by 2 sigma square. And last one has 1 by 3 sigma square. So out of this 3 by 8 sigma square, 7 by 2 and 1 by 3, which is smaller? How to find? Do you know? 3 by 8, 7 by 2 and 1 by 3. How to find out the smaller number? করে দেখো তো কোনটা, মানে এটা পারবে তো করতে? পারবে তো করতে এটা? যদি অন্য কিছু ভ্যালু থাকে, মানে এটা তো নিশ্চয়ই পারবে, আদার তুমি এটা নর্মালি ডিভাইড করে দেখতে পারো, আদারওয়াইজ another simple way to find out the fractional order. So it is 3 by 8, then 7 by 2, last one is 1 by 3. How to do? Easily. Just see, just cross multiply. 3 into 2, কত? 6. 7 into 8, 56. So 56 is more than 6. So first we are comparing these two. So obviously 7 by 2 is more than 3 by 8. So now we will compare 3 by 8 with 1 by 3. So 3 by 8 and 1 by 3 cross multiply karo, 3 3 9 and 8 into 1 8. Clear? So 9 or 8, which is greater? 3 by 8 is more. So 3 by 8 is more than 3 by 8 is more than 1 by 3. So 1 by 3 by 8 থেকে 7 by 2 is more. So obviously 1 by 3 is less. This is the way to find out. Is it clear?
Yes, ma'am.
Okay. So another some statements are there. Like suppose let x1, x2 to xn be a random sample drawn by SRSWR with E of xi equal to mu, V of xi equal to sigma square. Show that the sample mean x bar is MVUE, means minimum variance unbiased estimator for population mean mu. You have to prove this statement. So how to do? You know that E of xi equal to mu, V of xi equal to sigma square. Now x bar is equal to this. This is already known to you. You know that x bar is minimum variance of UE of mu if E of x bar equal to mu and B of x bar is less than Bxi. So just do it. You know how to find out E of x bar, that is mu, and V of x bar, you know, sigma square by n. Now, how can you say this is when for minimum variance, for minimum variance, this is okay. But for unbiased, minimum variance unbiased, MVUE full form is minimum variance unbiased estimator. This is unbiased estimator, it is okay. But how can you call minimum variance? To be minimum variance, you know that if just see how to find out the minimum variance. Your estimated sample variance must be less than. So from this formula, V of x bar equal to sigma square by n, we can say if n is greater than 1, then this value will be less than sigma square. If n is greater than 1, we can say this sigma square n will be less than sigma square. So we can say the sample mean is minimum variance with unbiased estimator of the population mean mu if n is greater than 1. Clear? Similarly, in the same case, if you do SRSW over, in the same case you have this factor, and from this factor also you can see that if n is greater than 1, then also this uh, value will be less than sigma square by n. So automatically we can say MVUE, minimum variance, this condition is satisfied. And the next part is the method of point estimation. There are several methods of points, two methods of point estimation. First one is method of moment. Method of moment means what? That means the sample moment. So moment one, zero moment, one moment, right? So sample moments and the population moments are equated. And finally, what equation you are getting, with the basis of on the basis of that equation you will estimate the population parameter. That is called the method of points. But আমি আরেকবার বলছি, in this method at first we equate মানে we assume that the sample moment and the population moment are same, like in respect of moment one, in respect of mu, we brief at the beginning we assume that the sample mean and the population mean are same, like this. So uh, at the beginning we assume that the sample moments and population moments are same. So by equating these two moment, we will get a equation, and on the basis of those equation, that equation, we will estimate the population parameter. So this is way, this is another one way to point estimate. So if x1, x2 to xn be random sample of size n drawn from a binomial distribution with parameter m and p, this you know, in binomial distribution these are the parameters m, p, then obtain the moment estimated of p and verify whether it is unbiased estimated or not. You have to verify whether the population mean and the whether the sample mean is estimated of population mean and it is unbiased. That you have to prove. So key boleche, this is under method of moment. So at first you have to equate the sample moment with population moment. So in binomial distribution, this is the probability mass function. In binomial distribution, this is the probability mass function. In the first chapter, you learned already. So the two parameters are P, M and P. And we know this formula, that is expected value of X is equal to MP. This value you know. E of X is equal to MP. And similarly, in terms of sample, you know that x bar is equal to 1 by n summation of I equal to 1 to n xi. So our motto is first we will equate the sample parameter sample statistics with the population moments, right? So this is the sample moments, that is MP. This is the population. This is a sample moment X bar, and this is the population moment MP. Because when we will talk for a particular statistics, we have to for population we will to take the for the simultaneous particular parameter. If you are talking, if you are dealing with average mean, then you have to for both case, for sample and for the population, you have to take the same statistics or parameter. That is why it is called moment. So if you are taking the mean moment, so you have to take sample as well as population. So we at first we will equate those. So MP, this is sample, this is population moment, this is sample. Both are in terms of mean. So we can write MP is equal to X bar, and from this we will we will write that p cap is equal to X bar by mean. About why I have we have given the bar this cap, because we are estimating, you know, in the first case, in the uh, beginning of this lecture, we know that we use this cap, just a minute, to denote the estimator, right? We use this cap to denote the estimator. Yeah, we use this cap to denote the estimate. That is why it is cap. So don't confuse with this. So just write P cap is equal to X bar by from this formula. So expected value of P cap. Expected value of P cap. I have to ensure that whether my P cap will estimate my population P. That is my motto. That is why we have taken expected value of P cap. Expected value of P cap will be equal to expected value of X bar by M. So we can write 1 by M, expected value of X bar. E of X bar, you know the formula, E of summation of I equal to 1 to N Xi by M. So this is 1 by M. Again, you take 1 by N outside. So 1 by M into 1 by N, summation of E of Xi. So E of Xi is what? E of Xi is equal to, for this is, we are doing binomial distribution. Don't confuse here. Don't write here mu. No, this is binomial distribution. So you can write in place of E of Xi, we can write MP. So write MP, but how many times? Summation of I equal to N. That is why this summation of I 1 to N means N times MP. You are adding MP N times. That is why N MP. By M into N, that is equal to P. So you see, your P cap is equal to P. Your P cap is unbiased estimator of P. There is no other factor. E of t equal to theta. So P cap is unbiased estimator of P. So your target is clear. So we can say, because they have given you to find out the moment estimator of P, and you have verified also that P cap is the unbiased estimator of P. Is it clear? It's very, very easy. Please tell me if there is any doubt. Please tell me. No doubt is there, right? So now we will do the same thing for Poisson distribution. You know, the PMF of Poisson distribution is this: e to the power minus lambda, lambda to the power x by x factorial. So, and you know the E of x is lambda. These are already done in the first chapter. So E of x equal to lambda, and you know the sample bin is this. So just equate those. X bar lambda is equal to X bar. So lambda, that is X bar, is moment estimator of lambda. So we just find out E of X bar is equal to, because they have given you to find out the moment estimator of lambda. So x bar is the moment estimator of lambda. So we can write, we will find out E of x bar, that is this, um, E of x equal to lambda. So n times lambda, so n lambda by n and equal to lambda. So you see E of t equal to theta. The formula is following. So E of x bar equal to lambda means x bar is unbiased estimator of lambda. So it is also verified. Next question for normal distribution, and they have the two parameters of normal distribution are mu and sigma square. And the question is obtain the moment estimator of mu and sigma square. So for both cases, we have to find out. So what is the moment estimator of mu? Just see, just we know E of x equal to mu and V of x equal to sigma square. So directly we can, for the mean, we know x bar equal to this. And for the variance, we know the formula. If we do in terms of capital S, we can write this is the formula, right? Just hold on. So you know that x bar is the moment estimator of mu. So we can write mu cap is equal to x bar. And similarly, we can write in for variance, we can write sigma square cap is equal to s square. Now we will see whether it is true or not, because here just you see we have written the moment 2 is capital S for equal to this. So whether it is right or not, we will see. So for mean, we can write E of mu cap is equal to E of x bar is equal to this 1 by n, this, that is mu. So you see x bar is unbiased estimator of mu. So your estimation is correct. So it is verified that x bar is unbiased estimator of mu. But next you have to check sigma square is unbiased estimator of capital S square or not. Just see to the E of S square. E of S square is equal to E of this. Just put the formula, and we can say 1 by n outside E of xi minus x bar whole square. So if you just multiply in for both numerator and denominator with n minus 1, we can write this is x, because we have to come with the equation, right? There is no formula there. This is the formula for a square, but if we do with the formula of small a square, we know the equation of small a square is with 1 n minus 1. So if you just write n minus 1 here and multiply with n minus 1, so you can get this formula, that is summation of I equal to 1 to n xi minus x bar whole square by 1 n minus 1. And this is the formula of small square, where uh, we are taking that one unit less than population due to the degree of freedom is decreasing by 1 unit. So we are come with this formula. So this is nothing but small square. Just we can write n minus 1 by n e of small square. So small e of small square. E of small square, you know that is sigma square. E of small square, you know that is sigma square. Because we know that the a square is unbiased estimator of sigma square. So we can directly write E of a square equal to sigma square. But you see, but for capital A square, the formula becomes E of a square equal to n minus 1 by n sigma square. So this does not follow the formula E of t equal to theta to be unbiased. E of t equal to theta, এটা ফর্মুলাটাকে follow করছে না, because n minus 1 by n this factor comes. So we can say capital A square is unbiased estimator, sorry, capital A square is biased estimator of sigma square. For this factor, capital A square is biased estimator of sigma square. Whereas we know the small a square is the unbiased estimator of sigma square. This is already proved here earlier. এখানেই আগে প্রুফ করা হয়েছে যে স্মল স্কয়ার ইজ দ্য আনবায়াসড এস্টিমেটর অফ সিগমা স্কয়ার। ক্লিয়ার হচ্ছে? দেখো বুঝতে পারলে কিনা। দেখো বুঝতে পারলে কিনা, না বুঝতে পারলে বলো, আমি আবার রিভিশন করে দেবো। বুঝতে পেরেছো?
Yes, ma'am.
সবাই বুঝতে পারছো তো?
হ্যাঁ ম্যাম।
ঠিক আছে। And the next, it is given exponential distribution. নবনীতা, নবনীতা, okay. Acha. So next is exponential distribution. So in exponential distribution, this is the PDF theta e to the power minus theta x, and you have to obtain the moment estimator of theta. So just equate with x bar. So you know E of x equal to 1 by theta. So E of x bar is E of x equal to 1 by theta. And you know x bar, what is the formula? So you just equate this too. You will get theta cap equal to 1 by x bar. Now find out E of x bar. So from here you can easily understand that x bar is the moment estimator of theta. So we can write E of x bar is equal to this formula, and this is for exponential, this is E of x I equal to 1 by theta. So summation of I equal to 1 to n means n by n times 1 by theta. That is equal to 1 by theta. So here also you are getting the same formula. You can follow E of t equal to theta. That formula you can follow because this is 1 by theta is the parameter. So we can say x bar is an unbiased estimator of 1 by theta. So this is the way to get in moment method, in the method of moment. This is the method of moments where you can estimate with the parameters. And the next one is maximum likelihood method. This is another method where in this method you are what how can you do by getting the maximum value. Just see, among all the methods of estimation, maximum likelihood method is the most important method. This method is simple and it gives estimates that possess a number of desirable properties. Let x1, x2 to xn be random samples from population with PMF of DMF, PDF, then involving parameter theta. Then for a fixed theta, the function will be equal to like this, summation pi of I equal to 1 to n, function of xi theta, may be looked upon as a function of sample observation. So in maximum likelihood method, what happens? The theta is called, the parameter theta is called the likelihood function, and L is called the likelihood function of theta. You have to deal with the likelihood function of theta, that is L theta, and maximum likelihood method means the maximum value of L theta. That is called the maximum likelihood method. So the principle of maximum likelihood suggests that one should take that the value as estimator of theta for which L theta is maximum. Clear? And if theta cap be the maximum likelihood estimate of theta, then L theta cap should be maximum of L theta. Hence, theta cap be obtained by. So, how can you get the theta? When first you have to do the likelihood L, that is L theta is the function, likelihood function, and you do to get the maximum value. You just derivative of L theta will equal to 0 by getting this. You can get the value of theta cap. And for the maximize, the double derivative will be less than 0. If this follows, then we can say theta cap will be the maximum likelihood of theta. And another way also can be done, that is, if L theta is greater than 0, then log of L theta is monotonic increase function of L theta. So we can take log theta. So if you take log theta, then we can say dd in terms of in place of L theta, we can take log of L theta. So you again derivative dd theta, that means first derivative of log of L theta will give you equal to 0, will give you the value of theta, that is maximum likelihood value. And to maximize this curve, this must be less than 0. So if you just see one some example will give you proper idea on this. Just see, this is an example. So the question is, let x1, x2 to xn be random sample of size n drawn from binomial population with parameter m and p. Find MLE. MLE means maximum likelihood estimator of p for known n. This is the question. So what we can write? We can write the function of x1, x2 to xn with p, because p is fixed, so p equal to pi of I equal to 1 to n. This is the PMF of binomial population. Just write this. MCX, this is just write pi of I equal to 1, MCX I. Then you can write P of xi, that can be written as summation I equal to 1 to n xi, and Q is 1 minus P, and M minus xi. So how many times you are doing? So this is n, you are producting, right? So that is why pi. So M means n into n minus summation of xi of I equal to 1 to n. This is how we can write. So if LP is the likelihood function of P, then we can write LP is equal to this. This is the LP, and we have to replace Q in terms of P. Just write 1 minus P in place of Q. So we can, you are using the log. So log of LP, because this is the way to find out the maximum. So we take the log. So log of LP will be log of this total function. So log of this, these are multiplied, right? These are product terms. The MCX, these all are product terms. So log of this plus log of P, plus log of 1 minus P power something. So just because log of A into B is equal to log of A plus log of B. So there are 3 product terms. So we can write 3 addition. Log of this plus log of P of P to the power summation of I equal to 1 to xi plus log of 1 minus P to the power n P nm minus summation of I equal to 1 to xi. Just do it. How can you do? So this is, we can, when we are doing in terms of law, we can take it in terms of summation. So I equal to 1 to n log of MCXI, and this is nothing but a constant value. So it will be 0 plus summation. Acha, this is P power something, log of A to the power n is equal to n log A. So this power will come here. So summation of I equal to 1 to n xi log of P plus this is also power, it will come before nm minus summation of I equal to n xi log of 1 minus P. So from this, if you do ddLP, because this part is constant, so after derivative, this part will get 0. So DDP of log of LP will be what? This will be 0, and this one will be 1 by P with summation of xi. This one will be nm into 1 nm by 1 by nm by 1 minus p, আর এখানেও তুমি পাচ্ছ summation of xi by 1 minus p. So from here you will get this equation. And finally, if you to get the maximum value, you have to make it 0. So by make it 0, we'll get p cap will be this, that is equal to x bar by m, and that is same as the p equal to x bar by m. So we can say p cap equal to x bar by m is the MLE of p, because this follows, it is same, so it can be said it is maximum likelihood method. Using maximum likelihood method also we can estimate the population parameter that with the estimated p cap. So this is how this MLE of the population parameter is obtained. Clear? Similarly, in this way, in binomial, if you know the PMF PDX of all the distribution, you can do for every distribution. So for next poison population, if you have poison population, then also you can find out the MLE of lambda. Same formula, just write it. This is pi because this is in product form. So in product form, how can you product? In summation we write summation. In here, when product term is there and you have to do product times more times, then you have to write this pi form. Similarly, this is like this, e of minus how many times you are producing n, so e of minus n lambda into lambda of summation of x I equal to n, and some this is also factorial, right? So that will be also pi of I equal to 100. Whenever multiplication will come, then you will write pi. So the likelihood function L lambda is given by similarly. So this is the likelihood function of L lambda. This L lambda is equal to this. So again, you do the log of L lambda. You do the log of this. Then you will find after equating 0, we will get the value x bar, and you will get lambda is equal to x bar, and you will say that lambda cap is equal to x bar is a MLE of lambda. Same thing you were getting. So for normal population is also done. Here you can do in your home by doing the step. You will see the same thing we will get, that the condition of second order differential can easily. So from here you can easily find out that mu cap is equal to x bar, and you will get the MLE of mu is x bar, and MLE of sigma square is equal to this. So this you can get by doing in your home. For similarly, exponential population is also done. So this part you can understand. The same form, process is same in maximum likelihood. Just do it. The intermediate step, you please do it in your home. So today, this is up to this I have covered, and in next class I will do the next part with some numerical from the exercise. Clear? বুঝতে পেরেছো? নেক্সট ডেতে আমি বাকিটা দেখিয়ে দেবো, আর সাথে কিছু নিউমেরিক্যাল করিয়ে দেবো। তাহলে আমাদের মোটামুটি সিলেবাসটা শেষ হয়ে যাবে পরীক্ষার আগে। আর তোমাদের কিছু কিছু খবর আছে কবে পরীক্ষা? ডু ইউ নো অ্যাবাউট দ্য এক্সাম ডেটস অর এনিথিং?
মনে হয় 15 তারিখ থেকে।
কোন রকম পাওনি না, নোটিফিকেশন বা কিছু পেয়েছো কি?
না।
আচ্ছা, এই শুনে।
হ্যাঁ ম্যাম।
আচ্ছা, ওকে দেন, থ্যাংক ইউ। তাহলে ভালো করে পড়ো, ডাউট থাকলে জিজ্ঞেস করো।
Thank you, ma'am.
Okay, welcome. Then I am closing.